That's okay. As you will probably have noticed, I've got a camera and I've got a microphone because I've had a few requests from people to record this for posterity, or at least for viewing in New York and Europe and a few other places. Don't know why, I'm not that famous. So tonight I'll be talking about Redis and Python. If you like me, you can follow me on Twitter, or you can read my blog, or if you want to buy my book, you can actually buy it now, read the first 6 chapters by following that bit.ly link. There'll be another chapter and an appendix next month, perhaps even a bunch of edits next month because we're going up for 2/3 review because that's how far I'm in on the book. And the plan is to finish within the next couple months because the wife is pregnant and she says, hey, it's got to be done before the baby comes out. If it's not, I'm in trouble. So, Redis and Python, or how I like to call it, it's PB&J time. In a lot of ways, Redis and Python match up very well in terms of functionality, features, and simplicity. And while I probably won't get into that a whole lot, if we have enough time at the end, I'll be doing some live coding where you will tell me the app to build and I will build it. Not the front end, but at least the back end, data access and updating API. So, without further ado, what will be covered? We'll start out with who I am. Then we'll move on to what is Redis. Then we'll talk about, well, why Redis with Python. And then we'll talk about some cool stuff you can do by combining them. So, who am I? Well, I'm a Python user of 12 years. Started my dorm when I was a sophomore. I guess really when I was a freshman, late freshman year, Python 1.5.2 came out and was posted about on Slashdot. And I'd spent a week trying to learn Perl, and that didn't work for my head. Recent research has suggested that learning Perl is equivalent to trying to learn random syntax. So I'm not to be blamed. But I picked up Python in an afternoon and rewrote all of my homework. And then subsequently wrote spiders with threading and to download webcomics so that I didn't have to wait to click on stuff to read stuff. And I'd start it before going off to class, come back, it'd all be done, and I could read hundreds of webcomics in an afternoon. It was pretty awesome. And from there I was hooked. So yeah, 12 plus years. I'm also a former Python dev bike shedder. And by that I mean that I spent about 4 or 5 years replying to about 90% of the threads on Python dev. If you're the recipient of any one of a number of those, I'm sorry. I was going to grad school and, well, thought I was smarter than I was. Yeah. I'm also the former maintainer of the Python async sockets libraries. I say former because I was working on them as a result of bike shedding. Guido said, you know, if nobody takes up maintenance of this stuff, it's going to be gone in Python 2.6. So I picked it up for 2.6 and got it released, and nobody decided to delete it after that. I also ported it to Python 3, but now there's a guy named Giampaolo Rodola out of Italy who's currently maintaining it. He also works on PyFTPD, which is actually an awesome Python FTP library. I've used it in the past, and I'm currently using it. If you need Python FTP server, use it. If you're actually serving up files, it's actually faster than some commercial FTP daemons on Linux. I'm also the author of a few small open source projects, in particular RPQ, the Redis priority queue. So if you need queuing and tasks in Python and Redis, you can use that. If you need cron tab parsing in Python, got parse cron tab for you. If you like to do async HTTP requests using the core Python async libraries, well, there's now a project to do that. And it supports some OAuth stuff and SSL and gzip compression, all that other stuff that other people apparently found hard. There's also time zone utils for parsing time zone shapefiles and spewing them out in JSON format. So if you ever want to know what time zone people are in, well, you can. I also work on a project called Pipe, which has been out for about 9 years now. It's the editor that I use because I'm I'm that guy. So where have I been? Well, I worked at some cool places you've never heard of. I worked at a place called Networks in Motion, which did GPS navigation for cell phones. Their biggest project in the past had been VZ Navigator on Verizon cell phones. They've since moved on to iPhone with Gokivo Navigator and I think Android with something else. They've since been bought and are now called Telecommunication Systems after I left. I also worked at a company called Adly up until last fall. They do online Twitter advertising, primarily. I also worked at a cool place that you've probably heard of, Google and YouTube. I left them to join Adly, and, well, I was there for about 1 year and 9 months and built YouTube groups out, not the original one, the second one that was better, that no longer exists because, well, it apparently wasn't a product they wanted to continue, but that's what happens when you're an engineer. They delete stuff. And now I work for a place called Chow Now, which you probably haven't heard of, but you will. We do online takeout and delivery ordering. We're growing our restaurant base very quickly, and, well, hopefully soon we'll be growing our engineering staff. We'll see. I'm also a very heavy user of Redis. At Adly, I picked up Redis, built some applications with it, and became effectively obsessed with it and participated in the mailing lists very heavily. And by very heavily, easy 50, 75% of the threads. I would answer people's questions on how to use it, what to do with it, how to scale things, what they were probably doing wrong. And ultimately, that led to me writing the Redis in Action book. Apparently, because I was at the right time and saying all the right things, another author of a Manning book saw what I was doing and said, hey, this guy's really smart. And he got asked by Manning Publications who should write the Redis book. And it turns out they pointed me out, so I submitted a book proposal, which is how these things go, and they said yes. And so technically been writing it since November, but really only started writing it full-time, or at least evenings and weekends, since January. Right now you can buy it. There's 6 chapters out now. Next month there will be another chapter and an appendix, and we'll be working, or I will be working pretty hard to get it out by October or so, the rest of it. We'll see how well that goes and how much sleep I lose. Yeah, because working full-time and writing a book is not something I would wish on anybody. I also get to move in 2 weeks, do jury duty. Hopefully I'll get that deferred and do another presentation up in San Jose. And that's in the next 30 days. So yeah, pretty tight for time. So what is Redis? If you don't know already, Redis is an in-memory database and data structure server. Generally, it's limited to main memory. If your machine has swap space, you can use that, although your performance will suffer severely unless you're using SSDs. And even if you are using SSDs, it will probably suffer pretty bad. And, well, you'll probably run into write limits at some point because, well, none of it was really designed for swapping to SSDs. In the past, there had been a VM subsystem that would write out relatively unused memory to disk. That was deprecated in 2.2. Now 2.4 is the release, and 2.6 is in release candidate 5. There was also a version called Disk Store, which stored data on disk, which is a great idea in concept. It was meant to address all of the issues that the VM version had, but unfortunately, it became apparent early on that building a B tree was actually kind of difficult, and building a B tree is not necessarily what you want to do to back something that actually has high IOs. B trees are great for certain things, just not for writing a whole lot of data. So yeah, Redis, we call Redis a database as opposed to a cache because it actually has persistence. You can persist to disk via snapshot, which can be triggered based on manual interactions or based on a number of writes over a period of time. You can also sync to disk via append-only file in very similar ways to most modern databases. most modern databases, everything that you write to the database gets written to an append-only log, and then occasionally it will update the on-disk data structures. They do this just because you want to stream as much data to disk, and writing randomly is actually pretty slow. You can stream tens, hundreds of megabytes to disk at a time, but when you're writing randomly, your IOs go to, well, you can only do about 100 random IOs a second on a spinning disk. And if you're writing randomly and you're trying to insert a bunch of records, that's not going to work very well. And Redis understood this, which is why VM and disk store are defunct. Redis also has support for master-slave replication. That is, you can set up a master, which then syncs out to a slave. You can set up slave chains, so you can have a slave of a slave of a slave, which is great for multi-data center replication. And you can even have it spread out via trees. So you can have 10 replicas of a single master. There does not exist master-master replication. Don't try. If you try to set up two Redis instances as slaves of themselves, you're going to have a bad time. What's going to happen in that situation is, well, typically when Redis connects to a master, the master will fork a child process, sync that data to disk, and then send that data off to the slave. And during that process, it will buffer up all of any writes. And after it sends off that dump, it will then stream those writes off to the slave. If you set up two masters against each other, they will alternate who's dumping, and they will alternate who's streaming. And if you get lucky, you may get a write in there, but it will be a quantum write. It will disappear and reappear over time. Also, if you do something silly like try to use pub/sub, which I'll explain a little bit later, you may get messages sent over, you may not. You may get messages repeated. If you try to increment a value, say, you may get that increment replayed multiple times, or it may not happen at all. It's pretty interesting, but don't try. It's not going to work the way you expect. It does support client-side sharding. So you can set up a method by which you can shard your keys, and it will do that pretty faithfully and pretty reliably. Most of the libraries and all the languages do support client-side sharding, including the Python Redis libraries. I think even the Node.js, the PHP, and the Ruby, and the Java ones. So even if you're not necessarily using Python, you can still use those features. Now there is support ongoing, well, in the future for a platform called Redis clustering, whose attempt is to offer the same kind of multi-master replication that you get in other well-built cloud services. In particular, you've got a master for each of a group of pre-sharded keys that are synced off to a number of slaves. And if a master goes down, then the slave that was most up to date takes over as master for that block of data. And it tries to distribute the keys in a particular fashion so that if you have a master go down, then other machines in the network will take that load. It's not done yet. It will be done in the future. It's being somewhat postponed due to a feature called Redis Sentinel that should be out somewhat soon. It's currently the author of Redis's priority. Guy who wrote Redis is a guy named Salvatore Sanfilippo, who lives in Italy. He's a great guy, really smart. He's working full-time on it thanks to the contributions of VMware. And Redis Sentinel will handle the master-slave failover in case your masters die. I suspect it's very likely that that will become an integral part of Redis cluster, even though that hasn't been said, but we'll see. Redis, as a server, supports 5 data structures, publish and subscribe. In particular, it supports strings, lists, sets, hashes, and what are called sorted sets or Z-sets. I'll explain what those are in a second. And it also, as of Redis 2.6, which is in release candidate 5, it does support server-side scripting with Lua. I know what you're thinking. You're like, but this is a Python meetup. Why would we want to script things on the server with Lua? And it was not my choice, but actually Lua is a pretty good choice because there are a lot of things that you can do with Lua that perhaps are not as easy with Python. In particular, memory limits, processing limits, and easy interfacing with C. And yes, you can do easy interfacing with C with Swig, but not quite as easy as with Lua. So, what is Redis compared to other databases and caches? Well, let's start with memcached because that's the first thing it's compared to. So memcached is an in-memory, no persistence database that stores strings and counters. It's generally very fast and supports multiple threads. Basically, you can increment counters, you can set, get values. Anyways, so memcached is this primarily cache. They don't like to call it a database because it doesn't persist to disk. And so if your machine goes down, well, everything else goes down too. You lose all of your data. Now you can do client-side sharding with it. Again, very fast. Now it's primarily compared to Redis because Redis is also in memory. Although Redis is optionally persisted, it has data structures, not just strings. It's also very fast. Because I've got an internet connection, I can actually show you how fast it is. It supports server-side scripting via Lua, although it is single-threaded. And you're probably thinking, oh my gosh, how can something single-threaded actually be fast? And it turns out that if you're not doing anything CPU-intensive, you can actually totally do things fast. It does multiplex sockets via asynchronous sockets. I think it uses ePOL or KQ or whatever, the best thing that's available on whatever platform it's running on. Now, a lot of people like to incidentally compare it to MongoDB because it's one of those newfangled NoSQL databases. Now, MongoDB, if you already know, is an on-disk database whose speed is inversely related to its data integrity. If you've ever had a chance to use it, you'll know that if you actually want your data to be there, it's probably not going to run very fast. But if you don't care if your data is going to be there later, well, it'll be really, really fast. MongoDB stores data as BSON, offers master-slave replication, sharding, multi-master, some server-side map reduces, and database-level locking, which if you're trying to do queries, be careful if you're also writing to it, just as a upfront thing if you were thinking about using it. There's also this other database called React. It's primarily key value data store, kind of, sort of, but it also stores kind of JSON blobs. It offers pluggable data stores. It's on disk. There's multi-master sharding. Has a RESTful API, so everything's over HTTP. It also does server-side map reduces and is written in Erlang and C, so it's kind of scary on the one hand. On the other hand, it actually supports and does very well with map reduces and queries while you're writing huge volumes. And yeah, then you can look at it in comparison to something like MySQL and PostgreSQL, which are actual legitimate relational databases, both of which support on-disk in-memory databases, pluggable data stores, master-slave replication, sharding, stored procedures, even master-master replication on both of them if you can, well, PostgreSQL has got third-party stuff. MySQL has got built-in stuff if you use the right fork of MySQL. So all these store data in some way, and you can query them in some ways. But Redis is unique in the kinds of data that it can store. With a relational database, you're looking at rows of columns. You define your databases up in advance. Postgres has got a sort of key value thing, so you can kind of use it as a NoSQL database. But React and Mongo and memcached are also all NoSQL. You're not going to be performing a SQL query, although Mongo's got this kind of weird query language based on a funky JavaScript thing. So what kind of data structures? Well, first it's got strings, which are really just scalars of a few different types. You can have straight up character strings, which allows you to concatenate values to the end. You can get or set individual bits. You can also get or set byte ranges. Now, the character strings are very useful if you need to pack your data in very tightly. And technically speaking, character strings can be used to build any other structure in Redis. So if you were kind of a nut and all you had was Redis and the functionality of character strings, you could actually build everything else in them. I wouldn't suggest it. Well, actually, you'd probably need character strings in Lua, but if you had them, you could totally build anything. It also has supports for integers on the string data type, which is the platform long int. So you get 32-bit integers on 32-bit platforms, or you get 64-bit ints on 64-bit platforms. Now you can increment or decrement these by a varying amount. You also get a sort of auto casting. So if you set a value as something that could be interpreted as a base 10 integer, then it will kind of magically behave as an integer if you try to increment or decrement it. It also has support for floats, which is actually an IEEE 754 floating point double. That is a 64-bit float. You can also increment or decrement these values, and you also get a sort of auto casting. Now the doubles aren't there until 2.6, but it'll be out any day now. So, and it's pretty solid, no known bugs. So if you want to use it and help test, please do so. Maybe not in production, maybe in development, and then when it goes, actual release, then migrate in production. So yeah. Then there are these things called lists, which are doubly linked lists of character strings. In a lot of ways, you can think of them like a Python deck. If you don't know what a deck is, it's in the collections module. It allows you to push and pop data from both ends of things. The implementation differs between Redis and Python, but they work really well. They're basically strings. You can, after you insert things, you can perform blocking pops of them or non-blocking pops of them from multiple lists. So you can implement prioritized task queues very simply and easily, at least on a high, medium, low kind of priority. You can also pop from one list and push on another, so you can say, hey, have I executed this before? You can also get, set, or search for individual items in a list. Maybe not set for individual items. I can't remember. I don't really use lists all that much. I use some of the other structures very often, but you can get and search for item and remove them. And also lists are sortable. Redis has got a method by which you can sort lists based on the content in the list or based on keys exterior to the list. It's actually pretty flexible. It also have these things called sets, which are very much like Python sets. They're a unique unordered sequence of character strings that are actually backed by a hash table. You can add, remove, check membership. You can pop items from the set. You can even randomly pop items from the set. You also have support for set intersection, set union, and set difference. You can use these things for, well, a variety of useful purposes. My personal favorite is for search engines, which we'll talk about in a minute. Sets are also sortable, which turns them into a list. You can store the results in Redis, or you can receive them as a result of a call. Redis also has hashes, which are very much like a Python dictionary. They're key value mappings inside of a key. You can kind of sort of, well, you can get, set, and delete single or multiple items. You can think of them kind of as a namespaced subRedis. You can again increment values that can be interpreted as ints or floats by ints or floats. You can also bulk fetch some set of keys or some set of values or both. And like I said, it's sort of like a small version of Redis. Then we've got these crazy things called sorted sets. Now, sorted sets are a lot like a hash with members and scores as opposed to keys and values. And really, you end up in a situation where scores are limited to float values, but you actually get a lot out of it. You can still get, set, delete, and increment these scores, but you can access the member names and the scores by the sorted order of this score member pair. In that you can access them by score, or you can access them by index. If the scores for 2 or more values happen to be the same, the values then relatively sorted based on the member. So then there's also this thing called publish subscribe. If you've been using things like, if you've been using GUI libraries like Qt or WX-Python or GTK, you will have come across this idea before. Basically, if you want to read some data, you subscribe to channels, which are either exact strings or patterns. Writers publish these channels, broadcasting to all subscribers. You can think of these channels as kind of a radio station. You're listening for something that is being broadcast and other people send to you. And unfortunately, messages are transient, so if you're not waiting on them, or if you're not listening, you will lose the message. In the past, I've personally not used them terribly much, because in the past, if you had a slow reader, Redis could wait to write on things and your memory could explode and you could be killed by the Linux out-of-memory killer. Nowadays, that is all addressed and there are settings for it in Python 2.6. I can't remember if it's in 2.4. I'm still stuck in my old ways of not using a feature. So, why Redis with Python? Well, I personally have opinions as to why Python is so powerful and why people are using it. It starts with reasonable syntax and semantics. You are probably all Python users because you sat down, you used it, and you're like, hey, this is not crazy. Or maybe you were introduced to it by a fellow programmer or by a job that you took, and you discovered, hey, you know, this whole indentation thing, no curly braces and all this other stuff, this actually isn't so bad. And in fact, it's pretty awesome. I know I've personally been using it for 12 years. I know a lot of people have been using it for the 20 that's been around. But that is a great power. Now, why is it so powerful? Well, I would argue it's because you can easily manipulate data and data structures. If you've ever used the C standard templates library, or you've ever used Java structures, or structures in, well, many of the other languages that are out there, you'll know that it's not all that easy to say, hey, I want a hash that has, or a dictionary that has different kinds of values and different kinds of keys, or a list of different kinds of values. You know, these kinds of things where you don't need to type things is somewhat unique and interesting to a scripting language, but Python has gone so beyond scripting, hopefully you all agree, that, well, arguably it's beyond scripting because it's actually very difficult to script the command line unless you're using something like IPython. But it has amazingly easy manipulation of data and data structures, which is how I got into it, because I'm actually a theoretical computer scientist, and being able to manipulate these things quickly and easily is very important to me. And finally, the power of Python lies in its large and growing community. It's one of the faster growing communities out there, and it is what? It's in the top 5 of the TIOC language listings, so it's growing and it keeps getting bigger every year, and for many good reasons. Now the power of Redis also lies in reasonably sane syntax and semantics. Aside from some slightly confusing things with, hey, some auto casting to integers and floats, it behaves almost the way you would expect it to. It also has easy manipulation of data and data structures. You only get one level of structures. You don't get to nest structures, but that's okay because you can namespace your keys and get effectively the equivalent of nested structures. And it has I would say, a medium-sized community that is also continually growing because of all the other features that it has. It's also available as a remote server. Now, when I first ran into Redis and I started using it, I was like, God, why didn't I think of this before? You know, I've had to build little services that basically just stored some small amount of data in some sort of Python data structure and manipulated them. And I never thought to myself, you know, wouldn't it be awesome to just have a shared data structure server? And here Salvatore came out and said, well, this is what we need. I'm going to build it. And just a breath of fresh air. And it's so different from anything else that's out there. And it's such an obvious solution to so many problems. And it's so useful that people think of it, or at least I think of it, as like a remote IPython only for data. If you've ever used IPython as the server with a little web interface, you can create notebooks and you can manipulate Python, you can store code, you can build amazing interactions with it. You can do the same thing with Redis. You can sit there in a little Python console, or you can sit in a Redis console and you can manipulate your data, or you can script it from Python. And actually scripting it from IPython would be pretty awesome too. But really it's so useful that people have actually asked for a library version of Redis. They're so discontented with their native language's support for data and data structures, they actually want to be able to access it in memory as opposed to via remote server to bypass the socket communication to get their interactions even faster. Which really says a lot, because a lot of people who come and ask for this are actually coming from C++, which makes me giggle quite a bit, because I spent about a year doing C++ professionally, and it was a nightmare. But that's just my opinion. If you like C++, I'm sorry. Sorry that you like it, not sorry that I said bad things about your favorite language. Now, to show the power of Python, or Python combined with Redis, this is a per hour and per day hit counter analytics in Redis with Python. So, can you see the cursor up there? Yeah, we can. Okay, so pick up some IMAP, we import the Redis library, and we're going to get a prefix on the keys that we're going to be modifying. I'm going to create a Redis connection, and then we're going to map over the lines in the log file a simple function called parseLine, which I don't include. If you've got Apache log file lines or whatever kind of log file lines you have, which I would recommend actually just JSON log lines, just because then you can read them anywhere. You don't need to, all you need to do is find that first curly brace, you pull that out and parse it, and everybody's happy. You don't need to do any funky, well, these fields can have spaces in it, how do I parse this crap? None of that, just anyways. Sorry for that digression. But say that this parseLine function returns an object with a timestamp attribute and a path attribute, which we use down here. And that timestamp, say it's a date-time object, you can turn it into ISO format. You can pull out the stuff up to the first colon, which is the hour. And you can pull out the stuff up to the T, which is the date. And you can increment the counters, or you can increment the entries in the Z set with the member names of log path at the keys prefixed at the hour and the day. And that's it. Now we also expire these after a week and after a month, a week for the hourly, a month for the daily, and this is it. Now, unfortunately, as is, this isn't terribly fast because it's actually making 4 round trips to Redis for every log line. But we can do better than that. We can do the same thing using what is known as pipelining, where you batch up a sequence of commands and you execute them against the server every number of trials. And we can do that by basically replacing the connection with a pipeline, which we signify by calling the pipeline method on a Redis connection object. I use false because we don't want to use transactions, which I can explain later if you'd like. And we do all the same things, and the pipe actually batches up all of the commands until later, where every 1,000 lines, except for the first line, where every 1,000 lines, it executes off to the server. So if you've got a 1 millisecond or 10 millisecond or 100 millisecond round trip time, well, now you can divide that by 1,000, or 4,000 in this case, and you can get significant speed ups in the performance of your clients. Now, I personally prefer 1,000. I don't know, it just has always seemed to work for me. Depending on the commands that you're running, that the best number may be higher and or lower. So I talked about using task queues before, so let's get into task queues. here's a very simple task queue that will add and run items. I'm going to use JSON to pack in the name of the function it's going to be called with arguments and keyword arguments. And basically, all we're going to do is push onto a list named queue the dump of the name args and keyword args. And this is sufficient to enqueue an object. And we'll build a helper in a little bit later so you can see that it can be really easy. And if you're a long-time user of Python, you'll already understand how easy this can be with decorators and a little bit of metaprogramming. And then execution is just as easy. To execute a single item, we can pass in a list of queues. And Redis actually has a function to pop in a blocking manner from multiple queues. We can even provide a timeout so that you're not waiting forever, so that you don't need to send a signal to it. You can say, hey, after 30 seconds, stop waiting for this, and if you didn't get anything, great. Now, I was a little bit lazy here, and I didn't handle the case where it returns the none, but that would be another line. And then we execute the function based on the name, the registered name of the function. So how do we register stuff? Well, here it is. We can register tasks. We just create a registry, and we set up a task decorator that optionally takes a queue. And we're going to skip past this body. We'll get to that in a second. And we check to see if somebody passed the name of a queue or if this is the first invocation on a function. And if it was provided with a string for a named queue, we return the wrapper object up above that expects a function. Otherwise, we call the queue the default queue, and we say that the function was what was passed in, and then we wrap that function. And then inside the wrapper function, we create a deferral object, or something that will defer calls to that, which actually internally we'll call the add item function. And we'll do some magic to make sure that the function is not in the registry. I didn't test this before I came in, but I'm 99% certain it's correct because, well, Python is that easy and Redis is that easy. Also, this has no Redis code in it. It's all Python. And yeah. So how would you use it? Well, here are two tasks. The first one, we can create a task in the high priority queue. And see, we pass the name of the queue. And so do something. If you tried to call this function, would actually pass that argument off to the deferred task, which would then execute if somebody called the execute1 function. Or we can omit that queue name, and we can just pass it as a task. And it's this interesting, funky way. If you've not seen this kind of thing before, well, download the slides later and learn that pattern with the 3 nested decorators or the 3 nested functions for a decorator. I use it whenever I can for optional arguments that you don't have to do that funky, hey, I'm going to create a decorator with no arguments thing. I never like that. All right, so yeah. So what are some other cool things you can do with this? Now, these cool things to do are more or less based on stuff that I've done personally or stuff that I've already written about in the book or stuff that I'm in the progress of writing about in the book. Now, these don't encompass everything that is possible with Redis, but it does encompass, well, a lot of the cooler things. Now, there are other things that have taken a variety of these different tasks, combine them together into larger applications. And I can talk about a few of those that I've personally done myself, and some that I've helped other people do as well. So, first thing you could build is Reddit. If you don't know about Reddit, I don't know how you've been around the tech scene, because everybody links to Reddit links and everybody uses Reddit nowadays. I I won't say that I knew about Reddit before it was popular, because I came from Dig when the redesign happened, like a lot of other people. Although I don't get a chance to read Reddit quite so much anymore because, well, work, book, wife, life. You can also do caching. I talk about a few different ways of doing caching in the book, but you can cache database entities to improve performance. You can cache often read data. You can use it as a way of storing pre-calculated values. So you have something that takes hours to run, and you just throw it in Redis, and now, hey, you've got something that takes hours to run, and you can cache it forever. Very similar to memcached, but it's another use case. You can also use it for storing cookies. I know what you're thinking, but I already store cookies on the client. And if you're storing cookies on the client, you're probably doing something wrong. Not that people have been using cookies wrong for a long time, but I would argue they have. Things like login cookies. If you've been storing signed login cookies on the client, well, you have to do crypto stuff. And if you're doing crypto stuff, you've already lost the battle. Don't do crypto stuff. Other people have done crypto stuff. So stop. Instead, throw a token to the client. Use a UUID, and then store all of that information that maps to your actual user on the server. Just remember to use secure cookies. Okay? So if you're not using secure cookies, well, people are going to get their cookies stolen. People are going to log in as them, and well, you've just lost all of your security. So use secure cookies, store all of your cookie data on the server, and use a UUID to map into that. And you can put all of that data in Redis, which you can then use expiration to get rid of it after a time if you want to do auto logouts, or you can go and throw timestamps for when you want to expire this stuff in a Z set, and then you can go and collect information about how long people haven't logged in. You can collect information like, so this guy hasn't logged in 60 days, but in the past he's used the site, this often. There's amazing analytic stuff you can do just based on data you're storing in Redis. Speaking of which, you can do analytics. I showed a very simple counterexample. In the past and in the present, I actually spew all of my logs out to syslog, which is then piped into a Python daemon, which then parses the logs and spews updated counters into Redis. And I've got real-time counters for a variety of metrics. I have a meaning to open source a variety of libraries, and actually I owe a library to a friend of mine who asked, hey, do you have something that actually spews out to syslog and can read from syslog? And it just needs documentation, and then I'll release it. And then you can do the same thing that I do, if you're not already doing it. You can also use Redis for configuration management. And by that, I mean you can use a Redis instance to give you information about database instances, about Redis instances, about memcached instances, about users and passwords, although you probably shouldn't be storing users and passwords in Redis unless you're hashing the passwords using bcrypt or pkbdf1 or any one of those other things. But you can use it for configuration management, and I've actually got a section in my book about using it for configuration management, as well as analytics, cookies, caching, and Reddit. You can also use it for autocomplete. All that cool stuff you do when you're typing into Google and it says, hey, you want to find out about George Bush? George Bush is I'll let you finish that out. You can use this for that kind of a thing. If you're working in a company and you have any sort of internal admin interface, you can use autocomplete for find as you type, for customer lists, because I work for a company that deals with restaurants. We use it for restaurant lists. We use it for usernames. We use it for finding menu items. Back at Adley, we used it for client lists over some 90,000 clients. We used it for autocomplete on just about every single named entity that we had. We even had autocomplete on a searchable index of Twitter, which is actually pretty awesome. You can also use it for distributed locks. That crazy stuff where you go to update data and you want to know, hey, am I going to be blocked in the database because I'm updating rows that other people are updating? Well, you can acquire a lock before you do that in Redis. And rather than having to wait on the database, you can quick say, hey, is somebody working on this stuff? And if they are, you can bail out, or you can wait for them. You can do things intelligently rather than letting something higher level stop you from doing what you need to do. And related to that, you can get what are called counting semaphores. And counting semaphores allow you to say, hey, we want to limit access to 5 concurrent requests. You can do this in Redis. Incidentally, all of the code that I talk about in the Redis book is in Python. Eventually, there will be code in Java and Ruby and Node.js, but that's not done yet. Python is the first class stuff. And so all of the code that I talk about in this particular part, there are implementations of all of that stuff in the book. And like I mentioned, task queues. Yeah, I've already talked about task queues, and if you need a task queue with Python and you're not particularly interested in a library like Celery, there's also another Python Redis queue called ArcQ, I think it is, which is based on the Reddit, or not Reddit, the GitHub Ruby queue, which basically does non-delayed tasks, but RPQ actually does delayed tasks and cron scheduling and all those other things. Yeah. You can also get publish subscribe for distributed messaging. And incidentally, if you want messaging that is persistent, so you want to do point-to-point messaging or broadcast messaging, that's also relatively easily implemented in Redis. And I've actually got a section in the book on that. You can also build search engines. Now, I mentioned this earlier. Now, if you want, I can really get into search engines. But generally speaking, search engines are effectively set unions, set intersections, and set differences, along with some scoring shenanigans. And because Redis supports sets and zset, intersection unions, and differences, at least with sets, you can basically implement an entire search engine in Redis. Now, I wouldn't necessarily recommend it for really big stuff, but if you need a search engine for your company database, if you need a search engine for documents, you can build it in Redis. And my first application in Redis was actually to build a search engine for Adley. And after building it for Adley, then went on to build an ad targeting engine based on the search engine stuff that I'd already done. And then we went and built an entire Twitter analytics platform in Redis. Yeah. Also, you can build an ad targeting engine. Incidentally, if you buy the book, in 3 weeks, you will get an entire chapter on search engines and ad targeting. And you'll also get advancements over the Adley ad targeting engine. And you could actually use that to make money on the internet. So yeah, so buy my book, make some money. Yeah, you can also build Twitter. I'm actually starting on this particular chapter tomorrow. Hopefully, well, we'll see how long it takes me to finish, but this is an equivalent to the entire back end of Twitter on a relatively small scale, including the streaming API. So if you ever wanted to build a Twitter clone, you totally can. This would also support people who have millions of followers, so you're not blocking on them. This supports lists, lists of people that are named. Yeah, and also the streaming API, which if you've ever consumed Twitter resources, all the third-party Twitter replication services that offer some sort of streaming support have a different API that sucks. Yeah, I looked at all of them, and no offense to any of them, but they could have done it better. And I blogged about it a year ago, and if they still stick with their crappy interface, they should be ashamed of themselves. You can also build chat rooms. I also blogged about that. And there's a gist on it that's like 300 lines that implements chat rooms, persistent chat rooms for a website. So that works on a pull-based method rather than having to be connected all the time. You can also do job searching. The chapter that I just finished writing, that'll be out next month, actually has a chapter or a section on job search. So you can find people who have job requirements, and you can actually do it in a scalable manner. So you can find, so a user can come in and say, hey, what jobs am I qualified for? Normally that's actually a pretty difficult problem. It's similar in concept if you've ever done any programming competitions to the pizza topping problem, where you're trying to find people that, you've got a group of people who want some pizza toppings, don't want other pizza toppings, and you want to find a pizza that matches the requirements and doesn't have any of the negatives. So yeah. And many, 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 many more applications. For example, Twitter is basically a bunch of hashes combined with a bunch of Z sets and combined with some task queues. Analytics, depending on what you're doing, is probably a bunch of Z sets, maybe some hashes, perhaps some lists for queues because you want to defer analyzing this stuff. I've seen some people actually use, and personally I've used, strings with the individual bit and substring manipulations to hold counters inside byte strings for sequential IDs. Say, for example, you wanted to know something I've actually done, you wanted to know the location of every person in Twitter. Well, generally speaking, at the time we were doing this, there were about 150 million users that we'd add information for over a range of 350 million sequential IDs. Well, turns out you only need about 3 bytes of data per user. Well, 350 times 3 is only a gig of memory. In a gig of memory, you can store the location information for literally every single user in Twitter. Whereas if you were to use a hash, which we had originally done before we switched over to using strings, it turns out that takes about, what is that? It takes about 16 gigs of memory. So you need kind of a big AWS instance, or you need some other very large instance. Also, if you thought about, we had been using a Z set as a priority queue for users whose information we need to repeatedly pull. And as a Z set, it turns out that 150 million entries takes on the order of about 34 gigs of memory. And it takes about 5 minutes to dump and about 30 minutes to load, which is kind of a pain in the butt. But if you instead store just either 4 bytes, or we actually got it down to 2 bytes per user, well, now you've got half a gig of memory, and you can scan over your data to find users that you should pull, and you can stuff, say 10,000, 100,000 of them into a Z set at a time, and boom, you've got huge memory savings, you've got similar kinds of priority queues. All you need to do is scan over that giant string, and problem solved. And incidentally, this Twitter analytics platform, we had started using the standard data structures in Redis. We've been using on the order of about 80 gigs of memory on 2 of the big 68 gig boxes in AWS. After we really started thinking about memory, dropped it down to about 3 gigs of memory. So we had an entire analytics platform for Twitter that had location information, gender information, follower account, and a variety of other information, and about 3 gigs of memory. And dump to disk, it was like a gig and a half. So yeah, Redis is super powerful if you know what to do. In, I think, the next chapter after the Twitter chapter in my book, I'll be talking about all sorts of tips and tricks to reduce memory usage in Redis. If you're a new user, seasoned user, I'm sure there are things in there that you've not seen before. And if you've seen them all, well, how'd you get my brain? And that joke fell flat. That joke didn't. All right. So that's pretty much it. If you'd like, and you've got some sort of application that you've crunched in your head and have problems doing, or you butted your head up against in some other database, and you throw it out there, I can live code it for you and show you how easy it is to do with Redis. Okay? Questions? Okay, so the question was, people have recently been using message pack instead of JSON as a way of improving or reducing memory use for transferring and in-memory operations. I don't use message pack primarily because JSON is fast enough and small enough for me. Indeed, there are people that use it and use it very effectively. I personally like the readability of JSON. So if I'm pulling a key from Redis, like I'm trying to decide, why is this not working? And if I'm storing data in it and it's a packed JSON representation, I can just get the key and look at it. That's also why I generally don't use any sort of compression, no zlib, no gzip, no bzip2, when I'm storing stuff in memory in Redis. Because I like to see things. I don't like to have to run things through a few different programs just to find out what's in there. Now, Redis does not support message pack natively. There's been discussion of including a message pack library in Lua internal to Redis for the scripting stuff. And that'd be cool. I don't know if it's going to happen. That is ultimately up to Salvatore. Yeah. Other questions?
So you mentioned the persistence to disk. Like our experiences in the past with the persistence to disk, especially in something like AWS, disk can be worse than RAM. Like, what's the state of the art right now? Like, do you let Redis persist to disk, or do you manually suck everything out of Redis and dump it yourself in your own format?
So the question was, in things like AWS, disks are not necessarily great. They can go away. They're not necessarily fast. Do you use the built-in sync to disk stuff with the dumping or the append-only file, or should you do other things to manually sync stuff to disk? And generally, I'm of the opinion that data consistency is important. And the built-in constructs to Redis, like the snapshotting and the append-only file, is consistent. You can't guarantee consistency if you are walking over the keys and syncing everything to disk yourself. If you are using the Redis monitor command, you can actually watch command stream, or you can actually build your own Redis-like slave. So you receive the dump initially, and then you can write stuff out to disk. Now there is a Python library that actually, pretty sure it's Python, that can actually parse the Redis dump format. And you can also parse the commands. And so if you wanted to do an append-only file-like thing, but you wanted to store it somewhere else, like say React or whatever, or you wanted to store your append-only file in something like that where it's synced off to like 20 different locations simultaneously without loading up your main Redis server, you could totally do that. And it wouldn't be unreasonable. For my personal preference, I just prefer to use the built-in stuff. And if I'm running into limits, I use ephemeral disks in EC2, and I try to get a big enough box that I know I'm not sharing it, so I get all of the disks. And then I back it up as much as possible. Now, Amazon does have the new boxes that came out in the last day or two, which offers SSDs, two 1 terabyte SSDs. Those look like a huge win, except for the fact that they're they're pretty expensive, if I remember correctly. Something like a couple, $2,000 or $3,000 a month, which makes those 68 gig high memory triple X, whatever extra large instances look like kids play. But they do claim almost 100,000 IOs a second, write and read. So if you're concerned about IO, you could totally do Redis with append-only files, syncing every second, writing those SSDs. You could probably do pretty well. Although my concern at that point would actually be wear leveling and wearing out the SSDs.
Or you spin up the SSD box like once an hour, make it a slave, put it down, write it to disk, pump it to S3, turn off the instance, there went 50 cents.
That's a good point, although I think you're minimally charged for an hour at a time.
Okay.
Also, I don't think that they offer, do they offer, is that the spot or the on-demand?
I don't know the price.
Yeah, they actually, no, they don't do spot, they do on-demand, so yes, I guess you could spin it up and keep it for an hour and pay the $350 or $320, whatever an hour that they cost, and you've got a nice, amazing SSD. But if you're going to do that, then all you're really using it for is writing to disk really fast for the dump, and then blasting it off to S3. And I guess it depends on your, what you really want. I think the real advantage, though, is the append-only file and being able to sync every write to disk. Or you can even go and use something crazy like Postgres's key value stuff and write your own slave to Redis and write all that data into Postgres on that crazy SSD, which would probably use the SSD better than Redis. Not for any other reason other than Postgres was designed in mind with block allocation, whereas Redis was not, and so you'll get better wear leveling because of block aligned writes. I see your arm going up.
I was just going to ask, it sounds like you're using it as like your main database for most things. How do you deal with reporting and any kind of ad hoc querying of the data once you have it?
Sure. So the question was, it seems like I use Redis for a primary database, and how would you do some ad hoc querying for it? And really it depends. In some cases, I use it as a primary database. In other cases, I use it as something that can go away. And the advice that I always like to give people is always assume that your box can disappear. Because that's the reality we live in, especially if you're in the cloud, especially if you're on Rackspace, Linode, SliceHost, EC2, or any of the other providers. Boxes disappear. I know we all like to believe that these are going to be at least as reliable as the desktops that are sitting under our desk, but fairly consistently over the last 4 years that I've been paying attention to EC2 has had some sort of catastrophic failure where some, double-digit percentage of machines in some location have gone away. And that has happened pretty reliably every 6 to 9 months. I've been actually pretty lucky. We avoided it at Adley on the most part when I was there, and I've avoided it at ChowNow. But that stuff happens. And that even happens when you co-load. Who knows whether that disk is going to die? Who knows if some bad memory is going to corrupt your data? Who knows if you end up getting a lightning strike, or your colo happens to not have its backup generators up to snuff, or if the upstream power provider, whatever. There are how many different ways that this stuff can fail. And so whenever possible, I like to say, write it to disk, back it up 5 times, have multiple replicas. If your data is important, have it in multiple places, not just in Redis, not just on disk, but in multiple places in memory, multiple places in disk. The only way you can really win on that kind of a situation is if you just have so much redundancy. You can say, okay, well, 50% of the boxes disappeared. Well, it's a good thing we had 4 times replication, so we still got 2 replicas. Gosh, I'm talking for so long, I forgot the first part of the question. Oh yes, reporting and ad hoc queries. So what I like to do whenever possible is store in Redis the stuff that can disappear. Now, if I've been backing up reliably, then what I also like to be able to do is, if I care about those backups, be able to recover data from the last backup. At Adley, we had this Twitter analytics platform. When it was like this giant 70, 80 gigs worth of memory stored across 2 boxes. We couldn't back that up continuously. But it turns out 95% of that data was actually seeded from some data in a database. And so if we lost all of that data, we could recover 95% of that data by spidering the hell out of Twitter. That last 5% would have been really nice to have, but if we lost it, that was okay. On the other hand, we also, at 3 in the morning, stopped the world, synced to disk, backed that up, and kept daily backups for a week and weekly backups for 2 months. And so worst case scenario, well, so we got to go to yesterday. Or if something really bad happened with S3, well, then we got to go 2 days back. And we could recover a day to 2 days worth of information in about 4 to 6 hours. Or if we lost everything, we could recover 95% of everything in about 3 to 5 days. So now, that's just me being anal retentive. And the reason I'm anal retentive is because I don't like losing data. I'd had a bad experience with MySQL about 10 years ago, back when my IASM was the only data store for MySQL. And I've not recovered from it. And since then, I've always been doing my best to not lose data. Other questions?
So, not considering Sentinel as a high availability solution, what are some of your preferred high availability solutions?
Okay, so the question was, notwithstanding Redis Sentinel, what are my preferred high availability scenario or methods of handling high availability for master-slave failover? I don't usually do that, or I don't usually have automated solutions, primarily because I assume that automated solutions can fail. And if you assume automated solutions can fail, then about all you can do is sit on a pager, wait for it to happen, and SSH into your boxes and fix it. There are a variety of tools that I've seen. Gosh, there's one that was just posted about on the Redis DB mailing list. It was written in Python, and it uses, I think it uses publish subscribe very much like Redis Sentinel to distribute information. And the biggest difference between it and Redis Sentinel is a matter of timing and completeness. Redis Sentinel basically waits at least a minute to fail over, under the assumption that it's probably a network stutter as opposed to a complete failure. Depending on your use case, that may not be fast enough. I have a suspicion that Redis Sentinel will be hackable enough so that you could reduce those timeouts to, say, 2 or 3 seconds if you're really crazy. But then if you've got a long-running command, you may run into a situation where Redis is blocked on a long-running command, or even a fork syscall if you've got a big memory instance sitting in EC2. We can talk about why that is later. But there are some operations that can take a while, and so if you're running those long-running things and your Sentinel or your high availability daemon says, oh wait, it's taken longer than a second or 2 or 3 to respond, well, then you could fail over, you may lose data, you may end up getting machine churn as things come up and come down, things sync, whatever, and then you can end up in a worse situation than you started in. Redis Sentinel is more of a very conservative approach to these kinds of issues. Whereas other solutions that I've seen are a bit more aggressive. They'll wait 5-10 seconds, and that'll be about it. Mike, was that we got to leave soon, or we should?
We've got time for one more question.
Okay, so one more question. All the way in the back. How do you search for keys? Was that the question? How do you search for keys more efficiently? So in Redis, everything is key mapping to a particular kind of data structure, right? And so There is generally a global key space, although you can kind of namespace them with databases, numbered databases. And generally, there's a command called keys, which allows you to fetch the list of all of the keys. Or you can fetch the keys based on a wildcard. But in order to return that list, it actually needs to scan over all of the keys. And so if you have 1 million keys, or 10 million keys, or 100 million keys, Redis has to scan over all of them and has to pick out the ones and construct a buffer to send to the client. As you can imagine, for large amounts of data, that can be slow. How do you make that faster? Well, if I cared about keys, and I generally try to build my applications so I don't, what I would do is I would put them in a Z set with all the scores being equal, and then make sure that all of my keys are defined such that I can do prefix searches. Part of the autocomplete stuff in the book, I talk about actually, I talk about tricks of inserting items into ranges where you know your key is going to be, finding the indexes, and then pulling those out explicitly. Now, that's how I would do it, because I would think of it as an autocomplete. And as far as I can tell, that's about the best way that you can do it. But generally speaking, I just wouldn't use keys. And I wouldn't design my application around using keys, with the understanding that it's slow, or can be slow with large numbers of keys. And it's primarily meant as a debug tool as opposed to a way to build applications. Okay, well, I guess with that, that's the last question. And this was more meant as an introductory level talk. It wasn't meant to get in and be like, hey, so this is how we've implemented this in C on the Redis side of things. This is how you would do that kind of stuff. Mostly it was meant as a way so that you can see all of the interesting things that you can do, the kinds of applications you can build in it, and ultimately you can build almost anything you want in Redis. It's really a question of, do you have the memory, or really do you have the money to buy the memory to store all of your data in Redis? And is your data model such that you can lose data? Coming from a relational database side of things, you don't lose data, but in Redis, because it's in memory, unless you're using AOF, you could probably lose some data. Thank you. If you're in San Jose and have some money, you can visit the NoSQL Now 2012 conference late August, where I will be giving a more business-directed talk with maybe some code or whatever. So yeah, so thank you and have a good night. Thank you for coming, and thank you to Mike Christo for inviting me, and thank you to Graph Effect for hosting the food, booze, and drinks.
And I'd like to thank you to Cross Campus and Dan for having us.
Oh yeah, thank you.
It's going to be awesome.